Hello viewers, in today's session we are going to discuss an important concept from straight lines, and in this session we are going to discuss the concept of shortest distance between two skew lines and how to find out the equation of line of shortest distance, right? So here we have to find the shortest distance and equation of the line of shortest distance between these two lines whose equations are given in symmetric form, and these two lines are denoted by L1 and L2, right? So let us first quickly see the definition of shortest distance between two skew lines, and then we'll see how we can easily find out the shortest distance between two skew lines using a distance formula, right? So here we'll discuss the Cartesian approach. So now consider two lines which do not lie on the same plane, and suppose this is line L1 and this is line L2, right? And these two lines lie on different planes, right? So these two lines L1 and L2 are said to be skew lines if these two lines lie on different planes and these two lines are non-intersecting, right? And the shortest distance between these two lines L1 and L2 is the segment or the line which is perpendicular to both these lines, right? So suppose this is the segment that is PQ, and this PQ segment is known as the shortest distance between these two lines L1 and L2. So we can define the skew lines as two lines are said to be skew lines or non-intersecting lines if they do not lie in the same plane, and the straight line which is perpendicular to both of these lines, that is the non-intersecting lines, then this line segment PQ is known as the shortest distance between these two lines L1 and L2, and the length of this line that is intercepted between the given lines L1 and L2 is called the length of shortest distance. So in other words, we can say that if two lines are non-coplanar and non-intersecting, then the two lines L1 and L2 are known as skew lines, right? And this distance, that is PQ, which is perpendicular to both the lines L1 and L2, is known as the shortest distance between L1 and L2, right? So here let us see how we can find out this the length of this intercept, that is PQ, with the help of distance formula. So now to apply a distance formula, we need to find out the coordinates of this point P and this point Q. Right now, this point P lies on L1 and this point Q lies on L2. So let us apply the concept of the coordinates of a general point lying on a line, right? So here we are given the equations of the lines L1 and L2. So let us here write or introduce a scalar, say lambda, and here we can introduce the scalar that is mu, right? And for some value of lambda and mu, we have the coordinates of the point P and the coordinates of the point Q. So now from equation 1, we can write x plus 2 over 2 is equal to lambda. Then we have y minus 1 over 3 is equal to lambda, and z plus 1 over minus 1 is equal to lambda. And from equation 2, we can write x minus 1 over minus 1 is equal to mu, and y plus 1 over 2 is equal to mu, and z minus 2 over 4 is equal to mu, right? And here lambda and mu are some real numbers, right? So from here we can write x is equal to 2 lambda minus 2. From here y is equal to 3 lambda plus 1, and from here z is equal to minus lambda minus 1. And similarly from here we can write x is equal to minus mu plus 1, and y is equal to 2 mu minus 1, and from here z is equal to 4 mu plus 2, right? So here we have x y z, and these x y z gives us the coordinates of this point P for some value of lambda, right? So the coordinates of point P may be written as 2 lambda minus 2, then we have 3 lambda plus 1, and then minus lambda minus 1. And similarly the coordinates of the point Q are given by x y z for some value of mu. So here we have minus mu plus 1, then 2 mu minus 1, and then 4 mu plus 2, right? So now we have the coordinates of point P and Q for some value of lambda and mu. So now we need to find out the values of lambda and mu using the concept of direction ratios, right? So if we look at equation 1, then the direction ratios of the line L1 are given by 2, 3 and minus 1, right? So here we have 2, 3 and minus 1, and the direction ratios of the line L2 are minus 1, 2 and 4. So here we have minus 1, 2 and 4. So now the next step is to find out the direction ratios of PQ, right? So direction ratios of this intercept or the line of shortest distance can be obtained by subtracting these two coordinates. And let us take the coordinates of the point P as x1, y1 and z1. So x1 is 2 lambda minus 2, y1 is 3 lambda plus 1, and z1 is minus lambda minus 1. And the coordinates of the point Q may be taken as x2, y2 and z2, where x2 is minus mu plus 1, y2 is 2 mu minus 1, and z2 is 4 mu plus 2. And from vector algebra we know that to get the direction ratios of any vector whose endpoints here the 2 points P and Q are given as x1 y1 z1 and x2 y2 z2, then the direction ratios of a vector is given by here x2 minus x1, then y2 minus y1 and z2 minus z1. So we can now write x2 minus x1 as minus mu plus 1, then we have minus 2 lambda plus 2, then we have 2 mu minus 1 and minus 3 lambda minus 1, and then we have 4 mu plus 2 plus lambda and plus 1, right? So let us simplify these expressions. So we have minus mu minus 2 lambda plus 3, and then we have here 2 mu minus 3 lambda minus 2, and here we have 4 mu plus lambda and plus 3, right? So these are the direction ratios of PQ. So now let us apply the concept of two perpendicular vectors, right? Now see here PQ is perpendicular to L1, right? So this shortest distance PQ is perpendicular to the line L1, and similarly this shortest distance line is that is PQ is perpendicular to L2. And again from vectors we know that if two vectors have direction ratios, say a1 b1 c1 and a2 b2 c2, and if these two vectors are perpendicular, then we have this condition, that is a1 a2 plus b1 b2 plus c1 c2 is equal to 0, right? So let us apply this concept to form two equations, right? So PQ is perpendicular to L1, and the direction ratios of PQ are given by these numbers, and the direction ratios of L1 are given by 2, 3 and -1, right? So here we can now apply this condition. So A1 B1 C1 may be taken as minus mu minus 2 lambda plus 3, 2 mu minus 3 lambda minus 2, and 4 mu plus lambda plus 3, and a2 b2 c2 may be taken as 2, 3 and -1. So now we can write 2 times minus mu minus 2 lambda plus 3. Then we have 3 times 2 mu minus 3 lambda minus 2, and then we have -1, and we have 4 mu plus lambda plus 3 is equal to 0. So let us simplify. So we have minus 2 lambda minus 4 lambda plus 6. Then we have 6 mu minus 9 lambda. Then we have minus 6 minus 4 mu minus lambda minus 3 is equal to 0, right? Okay, so now here we have minus 2 mu plus 6 mu, that is 4 mu, and here we have minus 4 mu. So these three numbers get cancelled. Minus 4 lambda minus 9 and minus lambda is equal to minus 14 lambda, and this is here 6 and minus 6 get cancelled, so we are left with only -3. So we have minus 14 lambda is equal to 3. So lambda is equal to -3 over 14. So here the value of lambda is equal to -3 over 14. So now let us apply this condition to this one. So here PQ is perpendicular to L2, right? So now A1, B1, C1 remains the same, that is minus mu minus 2 lambda plus 3 as A1. B1 is 2 mu minus 3 lambda minus 2. C1 is 4 mu plus lambda plus 3, and A2, B2, C2 may be taken as -1, 2 and 4. So now applying this condition, we have now a -1 times minus mu minus 2 lambda plus 3. Then we have 2 times 2 mu minus 3 lambda minus 2, and then we have 4 times 4 mu plus lambda plus 3 is equal to 0. Let us simplify. We have plus mu plus 2 lambda minus 3, then we have 4 mu minus 6 lambda and minus 4, then we have 16, then we have 4 lambda plus 12, right? So now this is 4 mu plus mu is 5 mu, then we have 16 mu, that is 21 mu, right? And then we have here 16 plus 4, here we have 4 mu and minus 6 lambda, that is minus 2 lambda, and here we have plus 2 lambda. So these quantities get cancelled, and then here we have minus 3 minus 4, that is minus 7, plus 12, that is 5, right? And now we can write 21 mu is equal to minus 5. So mu is equal to minus 5 over 21, right? So now the value of mu is minus 5 over 21. So now we have obtained the values of lambda and mu, and taking the values of lambda and mu in these coordinates, we can easily find out the coordinates of the point P and Q. So let us substitute the value of lambda in this coordinate. So the coordinates of the point P are given by 2 times minus 3 over 14 minus 2. Then we have 3 times minus 3 over 14 plus 1, and then we have minus 3 over 14 minus 1, right? Okay, so now simplifying, we have here minus 6 over 14 minus 2, then we have 3 times minus 3 is minus 9 over 14 plus 1, and here we have minus minus plus, so we have 3 over 14 minus 1. So here we have minus 6 minus 28 over 14. Then we have minus 9 plus 14 over 14. Then we have 3 minus 14 over 14, that is minus 34 over 14. And this is 5 over 14, and this is minus 11 over 14. So the coordinates of the point P are given by minus 34 over 14, 5 over 14, and minus 11 over 14. So let us substitute the value of mu in this coordinate. So the coordinates of the point Q are given by minus, we have minus 5 over 21 plus 1. Then we have 2 times minus 5 over 21 minus 1, and 4 times minus 5 over 21, and here we have plus 2. So simplifying, we have 5 over 21 plus 1. This is 2 times minus 5 is minus 10 over 21 minus 1, and minus 4 times minus 5 is minus 20 over 21 plus 2. So this is 5 plus 21 over 21 minus 10 minus 21 over 21, and minus 20 plus 42 over 21. So this is 26 over 21. This is minus 31 over 21, and this is 22 over 21. So the coordinates of the point Q are given by 26 over 21, comma minus 31 over 21, comma 22 over 21. So now we have obtained the coordinates of point P and coordinates of Q. So let us find out the direction ratios of PQ, right? So we have here x2 minus x1, and then we have y2 minus y1 and z2 minus z1. So we can now write 26 over 21 minus 34 over 14. Then we have minus 31 over 21 minus 5 over 14. Then we have 22 over 21 minus 11 over 14, right? So this is 26 over 21 plus 34 over 14. and minus 31 over 21 minus 5 over 14, 22 over 21 plus 11 over 14. So now we have here the LCM of 21 and 14 is 42. So here we have now 52 plus 102, and then here we have minus 62 minus 15 over 42, and here we have 44 plus 33, right? Okay, so now we have 154 over 42, and then we have minus 77 over 42, and here we have 77 over 42. So here taking or cancelling the common factors, so we have here 11 over 3, and then we have minus 11 over 6, and then we have 11 over 6, right? So the direction ratios of the line of shortest distance is given by 11 over 3, minus 11 over 6, and 11 over 6, right? Now see here we can see that 11 over 3 is a common factor, right? So multiplying these numbers by 11 over 6, the direction ratios of the line of shortest distance PQ may also be written as 11 over 3 times 6 over 11. Then we have minus 11 over 6 times 6 over 11, and then 11 over 6 times 6 over 11, right? Because in these three numbers we have 11 over 3 as a common factor. So here we have multiplied these three numbers by 6 over 11, because here we have used the concept that if two vectors are parallel, then their direction ratios are either equal or proportional. So now we have here 2, and then here we have minus 1, and here we have 1. So the direction ratios of the line of shortest distance PQ are given by 2, minus 1, and 1. So now to find out the shortest distance, let us apply the distance formula, that is PQ is given by square root of x2 minus x1 square. Then we have y2 minus y1 square, and z2 minus z1 square. So we can now write here x2 minus x1. Now see, when we have calculated the direction ratios of PQ, we have obtained the values of x2 minus x1, y2 minus y1, and z2 minus z1. So x2 minus x1 may be taken as 11 over 3, right? So here we have 11 over 3 square, then we have minus 11 over 6 square, and then we have 11 over 6 square. So now we can write here 11 over 3 square, and then we have here 11 over 6 square, minus 1 square is positive, and then 11 over 6 square. So we can now write here 11 over 3 square, and then from here we can now write 11 over 3 square, and then we have here half square, right? So we have half square, and then we have 11 over 3 square, and here we have half square, because 3 times 2 is 6, and here also 3 times 2 is 6. So now we can write PQ as square root, and here we have 11 over 3 square as common. So we have now 1 plus half square, and then we have half square, right? So simplifying, we have here 11 over 3 square, and then we have 1 plus 1 over 4 plus 1 over 4. So taking 11 over 3 outside the square root sign, so we have 11 over 3, and then we have 1 plus 1 over 4 plus 1 over 4. So we can now write 11 over 3, and here we have 4, and then 4 plus 1 plus 1, right? So this is 11 over 3, and here we have root 6 over 4, and this is 11 over 3 and root 6 over 2. So this is 11 root 6 over 3 times 2 is 6. Now rationalizing the numerator and denominator by root 6, we can write PQ is equal to 11 root 6 over 6 times root 6 over root 6. So this is 11 times root 6 times root 6 is 6, and here we have 6 times square root of 6. So the length of the shortest distance, that is PQ, is given by here 6 and 6 get cancelled. So we have 11 over square root of 6. So this is the length of the shortest distance between the two lines L1 and L2, and PQ is equal to 11 over square root of 6 units. So let us find out the equation of the line of shortest distance, that is PQ. So equation of the line, that is PQ, is given by x minus x1 over a, y minus y1 over b, and z minus z1 over c, right? Because this is the symmetric form of the equation of a line, right? So the equation of PQ is given by this equation, and here x1 y1 z1 are given by minus 34 over 14, 5 over 14, minus 11 over 14, and a, b, c are the direction ratios of this line of shortest distance, that is 2 minus 1 1. So we have the equation of PQ as x minus 34 over 14, and here we have 2, then we have y minus 5 over 14 over minus 1, and then we have z minus 11 over 14 divided by 1, right? Okay, so simplifying, we have x plus 34 over 14 over 2, then we have y minus 5 over 14 over minus 1, and z plus 11 over 14 over 1. So again, simplifying, here we can now write 14x plus 34 over 28. 14 times 2 is 28, and then we have 14y minus 5 over 14 times minus 1 is minus 14, and then we have 14z plus 11 over 14, right? Now see, in the denominator we have 28 minus 14 and 14. So again here dividing these three numbers by the common factor, that is 14. So we can now write 14x plus 34 over 2. 14 times 2 is 28, and then we have 14y minus 5 over minus 1, and then we have 14z plus 11 over 1. So here 14 times 2 is 28, 14 over 14 is 1, and here again 14 over 14 is 1. So this is the required equation of line of shortest distance, that is PQ. So here it is interesting to note that we can also find the equation of the line of shortest distance PQ by using the coordinates x2, y2, z2. So if we use this coordinate, that is point Q, instead of point P, then we can write the equation of PQ as x minus x2 over A, then we have y minus y2 over b, and z minus z2 over c, where a, b, c are 2, minus 1 and 1, and x2, y2, z2 are given by 26 over 21 minus 31 over 21 and 22 over 11. So in this case the equation can be written as x minus 26 over 21, that is y minus 31 over 21, and then z minus 22 over 21, and in the denominator we have 2 minus 1 and 1. So simplifying, we have 21x minus 26 over 21 times 2, then y plus here we have 21y plus 31 over 21 times minus 1, then 21z minus 22 over 21 times 1. So here we can see that 21 is the common factor. So dividing these three numbers by 21, we can now write 21x minus 26 over 2, then 21y plus 31 over minus 1, and 21z minus 22 over 1. So this is another form of the equation of the line of shortest distance, that is PQ, right? So we can either use this equation as PQ, or this equation of this line of shortest distance PQ.